Tell me if this sounds familiar. You're working on a research project, involves a bunch of Jupyter Notebooks. Submit the paper, reviews come back a few months later, you open up a notebook, it doesn't run. Or you need to change something in one notebook and don't know how many of the other ones you need to rerun in response. Maybe you put some numbers in the notebook name so you know which order they need to run in. Maybe one's really expensive so you want to skip it, but you're afraid of publishing an incorrect result, maybe getting a retraction. Even if it doesn't get that dramatic, at the very least you realize this is a bunch of extra overhead that is contributing no value to the actual science. Here we're going to see how to solve these problems using the Calkit JupyterLab extension. We're going to turn a set of notebooks into a single button reproducible pipeline with automated environment management. Alright, so the first step is to head over to the Calkit installation documentation at docs.calkit.org. We're going to copy this curl command, paste this into a terminal. I'm on Mac OS here, but this same script will work on Git Bash on Windows, WSL, and Linux. It installs the UV Environment Manager, JupyterLab, and Python all at the same time, so you really don't need anything else on your machine to get started with this. Next thing we'll do, we'll go into our project folder. In this case, I'm going to call this Calkit and then just JLab demo. So go in there and run Calkit JupyterLab. You'll see here we have an example project I put together with 3 notebooks. They don't have numbers in the names because we don't need that anymore. You'll see up here in the notebook toolbar the additions from the Calkit extension. We have a badge for the environment, the pipeline stage, notebook inputs and outputs. So we'll start with the data collection notebook. This is a really simple kind of toy example. Creates 2 variables, x and y, puts them in a pandas data frame, saves them out to a CSV file called raw.csv. The first thing to do is define an environment for the notebook. So this is a definition of all of the packages that are going to be necessary to run this notebook, and this is going to be bundled with our project. So the suggested name here is the name of the notebook. I'm just going to call this main, and you'll see we have a shortcut button down here to add the PyData package group, which is just a collection of all the typical Python packages that you're going to want to use for data analysis, visualization, etc. So let's create that environment. It's going to set the kernel. Next thing we want to do is put this into the pipeline. So we have a suggested stage name here, collect-notebook. We have some options for how we want to store the executed notebook and an HTML version of the executed notebook. These can either be Git or DVC. DVC standing for data version control, which is good for larger or binary files. In this case, these notebooks are pretty small, so we're going to save them in Git. This notebook now has a pipeline stage. We see there's a play button here. It's orange, indicating that our results are out of date. We can look at defining the inputs and outputs. So for inputs, because this isn't reading any files, there are no inputs here. There is an output though, data/raw.csv. Let's add this in here as a notebook output. So data raw.csv. We can choose how we want to store the outputs, either DVC, Git, or none, to not store it at all. This is a relatively small CSV file, which is text, so we'll put it in Git. We can run the notebook with the play button up here, and this is going to restart the kernel to make sure we don't have anything left behind from the last run. Once it's done, our button turns green here, indicating that this output truly reflects the input notebook. We could make a change, let's say, to the noise level, make it a little bit of a noisier sine wave. See, our notebook is then stale again. We can rerun it. It's going to regenerate our raw data. We don't really have to think about that. Next, we can go through the same steps with our process notebook. Pick an environment for it. We can create a new one or reuse an existing environment. The downside to reusing an existing environment is that if you change it later on, any of the notebooks that depend on it will then be out of date. The upside is that you have fewer environments, but a project can have as many environments as it needs. Let's put this notebook into the pipeline. Same options here. Define our inputs. You can see we're reading data/raw.csv, and define our output, data processed.csv. And we'll also save this in Git because it's a relatively small text file. See in the sidebar, we have this orange dot here indicating that the pipeline is stale. We can see which notebook is actually stale here, and we can rerun the entire thing with the play button. One nice thing about this play button is that it's actually going to skip any of the stages that are already up to date. So you don't have to worry about which notebooks are expensive. Last notebook we have here is the plot notebook. So again, let's put it in the same main environment. Let's put it into the pipeline with the suggested stage name. We got to define inputs and outputs. We can see we're going to plot both the raw and processed data. So both of those need to be inputs. Data raw.csv, data processed.csv. and then define our outputs. Figures, raw.png, you can see those down here. Typically, you don't want to put binary files into Git, but these are going to be really small. So for the sake of simplicity, we're just going to put those into Git. Run our pipeline, you can see everything is up to date. Look at our figures. Take a look back at our data processing. We apply a rolling mean to the data to smooth it out a bit. Let's say we go back and change something about this processing. Maybe we want to only apply a 10 sample rolling mean. After we save this, we have 2 notebooks out of date. We can rerun the entire pipeline here. Take a look at our figures again. See our process data isn't as smoothed out. Everything is consistent. That's nice. We don't need to think about it. What if we go all the way back to the collection notebook and say that instead of 4 pi, we want to have 6 pi with 3,000 samples, and let's increase the noise level to 0.3. Again, just run the entire pipeline. Don't need to think about which notebooks are out of date. Of course, we're going to expect that our figures are going to change since we changed our raw data. Okay, so we have more cycles. It's noisier. The process data looks different as well. We don't see an orange dot here, means our project is good to go. So that's it. We just took a group of notebooks and converted them into a single button reproducible pipeline with automated environment management. The logical next step would be to add a pipeline stage for our paper. Maybe we could add a LaTeX stage so we could change anything about the analysis or visualization and have our PDF updated with that same single button. But that's going to have to be the subject of a future video. Feel free to leave any questions you have in the comments, and I'll see you next time.